Welcome. This question comes in two parts, and the first part says, how much charge can a 7 picofarad capacitor hold when a 4 millivolt potential difference is applied across its terminals? So here we have a battery which is providing a potential difference to a capacitor. So this is 4 millivolts. And this is 7 picofarads. You've got to be careful with the two symbols. For the battery or voltage source, it's a big line and a little line. If you think about it, it takes more ink to write a positive than it does a negative. So there's the sequence of the terminals. And for the capacitor, it's two just parallel lines. Okay. And the relationship is, well, capacitance is a measure of the amount of charge you can hold for a given voltage. So we have that. So if I rearrange this, I get that charge is equal to V times C. And in this case, my voltage is 4 times 10 to the minus milli is 3, and this is 7 times 10 to the minus 12. So Q is equal to 28 times 10 to the minus 15, and this is going to be in coulombs. And you can leave it as 28. You don't have to turn it to 2.8. And I certainly wouldn't do that in my head. I wouldn't do this math and also switch my position of my decimal point, because as many times as not you would go the wrong way on, or some people would go the wrong way on this one. Sometimes they'd go up, sometimes they'd go down. So just slow down and write more steps out and you'll make fewer mistakes. By the way, it's interesting. This is a small amount of charge. Let's just, for the fun of it, figure out how many electrons that would be. So we have the number of electrons equals the charge, which is 28 times 10 to the minus 15 over the charge of an electron, which is 1.6 times 10 to the minus 19. And if I work that out, what I get is it's going to be the number of electrons on those plates. On one of the plates is equal to 175,000 electrons. So there's 175,000 negatives on one plate and 175 positives on the other, 5,000 positives on the other plate. It gives an idea of the scale. And then on this one it says, which trace best represents the relationship between the charge on a capacitor and the potential difference across a capacitor. So again, it's the same diagram. I'm interested in the charge on the capacitor and the potential difference across the capacitor. Well, capacitance is a measure of how much charge you can get for a given potential difference. So if I think about this, I want charge, so charge is equal to V times C. And if I look at this, I can say, well, that's like my Y, because there it is, and that's like my X. Sorry, that's like my X. Let me get rid of that, because there it is. And so this is my slope, plus 0 plus b. Remember, y equals mx plus b. So this slope, the slope is going to be linear. It's a linear graph. And as v increases, q increases. So that means it's d. So there we have it.